using a plastic sheet in the ground. And it's because we have so much macropores in the soil. And when we are doing storing water into the drainage systems, it will leak out to the main drains, the deep ditches. And also when we are doing irrigation and pumping water into the drainage systems, it will leak out. What can we do for it? It's to use a plastic sheet to prevent or take the bypass flow away, so it stays in the field. And the important thing here is that we go to a depth where we have no macropores in the soil. Because if there are macropores under the blast film, the water will go under it and out to the main drain. And they will make for about a half kilometer per day with this system. But later, if we are going to use it, the machine will make 2 or 3 kilometers per day.
How deep is the soil cracking? I guess that's my question.
If you look at Finland, in this area usually it's around between 1.4 and 1.8 meters. I would say that more than 95% of the soils fall into that category. In this case, I think it's maybe 1.7 or something like that, the big cracks. Of course, you can have some small cracks in the bottom, but we are just below the soil cracks here. And we, as you may have noticed, we don't put it right up to the surface, this plastic. Yeah. We also have to leave some space for the plowing, and if we would get a lot of excess water, you could still get some flow out of the system. And indicators if you want to know the age of this soil, so you can see at what stage of the Baltic Sea they were sedimented. The salt content has been changing over time, so they are reflecting the salt content, and that way you could determine the age. And I think we have some people here who could determine the age of these shells. I cannot do it, but
the age of these shells, I mean, the same thing is still, the same species is still growing or not?
They are still living in brackish water in the Baltic Sea. But and in that level in Kvarken area, they are, because here is lower salinity nowadays than in Little Sea. They are a little bit southern where you can find in the actual Baltic Sea.
And so can you do carbon dating on these shells?
Yes.
So, Peter, the one problem that could arise in decades to come could be salinity. Accumulation of salinity in these areas, because you now have no more drainage, or you limited the drainage. So that would be the only limitation I could see. And my question was, when they were putting this drain in, digging it, they could have maybe put a tile drain or some pipe system, plug it, but in the event of 10 years time, if a salinity problem arose, you can unplug it. So that could be possible. Or monitor the areas to make certain it
You are completely right, and we have been thinking about this accumulation problem, and we are trying to monitor the soil to see if it would accumulate. But then on the other hand, here we have about half of the precipitation will be flushed out anyway. We will open the drain in the autumn, we will flush the system. We will have to do that anyway. So I think that we will not accumulate, but we are following it because it can be an issue. And especially in a drier region, if you pump in a lot of water, the water is evaporating and the salts are left in the soil. But here we are flushing it.
And your evaporation here isn't as high as other countries.
It's about 300 millimeters, and the precipitation is about 600 millimeters.
So in effect, you can calculate how long it may take for this to happen anyway. Model it.
Peter, the main drains here are quite deep. Have you looked at options to either could you make them shallower or manipulate the water level in the big drainage system? I think they cannot be made much shallower because there's still, even if it looks very flat, but you still have to have some slope in the drain. We are now 1.5 meters above sea level. In the middle it's maybe on par with sea level.
Yes, and that part of the crater is under the sea level.
Yeah. But one thing is, when we have a pumping station in one end, it means that potentially we will need to lower the groundwater level unnecessarily deep in one part, and it will drain the other part too much maybe. So it would be good to have some
control
traps.
Yes.
And as you saw yesterday at the map of Finland, some heavy metals will show so high contents that we have the bad chemical status here. It's the only area in Finland in practice which have it. Otherwise in Finland here they, how can I say, they don't meet, they fail to meet the objectives, as we say in the European Union. So they don't have the low level of metals, but they are very high during the flooding times. And therefore we have big problems, and we never can reach it during the next 15 years as it waited in the European Union program. We cannot, we don't succeed.
Is there any problem in maintaining the ditches, that they don't, you know, collapse on the side or fill up?
Yes, they have, and the bottom there's a lot of sediment coming to the ditches, and they have to
Clean them out?
yeah, clean them up. Yes, about 5 to 10 years.
Do you do any liming of the ditch walls after?
No.
That's an issue, the drains. When you put out the dredge materials, of course that will release some acidity, but think that you have 700 meters of this soil behind it. So in proportion, is it really the big issue? Is that the issue, or is it soil here behind? So I would say it is an issue, but it's still quite small compared to what's here in the field. But we don't see.
Feeling for how much water is going up and down versus how much water is going laterally in the system. I mean, evapotranspiration is always out, and rainfall is always down.
Yeah.
So
in a warm summer period, it will go about 10 centimeters in 1 week. The groundwater will drop. That doesn't mean that it will be completely dried, but at least it will not be saturated. So how many millimeters is that?
The evaporation is about 5 millimeters when it's all per day.
Per day.
50 cubic meters per day.
yeah, well, I think maximum Australia is maybe 8 millimetres. Very hot summer day.
Yeah.
What about low and high pressure systems and the variation in the water table in response to the ambient pressure change? Have you measured any of that?
We haven't measured it. We could do it. We have data from where we could measure that. I know that you have it in MacLeod's screen, but we haven't thought about it here.
Do you have some way of keeping the pipe slats from filling up over time and sealing? Or have you encountered sealing of the slotted pipe?
This system, we have to flush them every now and then, maybe every second year or so, in order to have them to work properly, because they will accumulate.
I need to ask the question about the distance of drainage pipes. So by many of us having some experience with the matter, the more far away we have those basic pipes doing drainage, now we are pumping water there. Personally, I have drowned my potatoes by doing that. So I'm very interested to know what is the optimum distance of those. We basically have how much in general, the distance between the pipes, drainage pipes. Would it be 25, 30 meters?
Here it's about 30 to 40 meters.
Yeah.
Yes.
And how is the water table reacting now that we are regulating?
We have to put them when they are so far. You have to put them a little bit deeper.
Yeah.
Before, do you have a water table between the pipes? Yes, and it's lower.
Yeah.
And when you are pumping water into the system, it turns around and you get a water table like this. So you have to think.
Yeah. What would you think would be the optimum if you redesign the whole system like here? What would be the distance between the drainage pipes or regulating pipes? For today's machinery, for today's cultivation. Yeah, but you can only make it one way, a right way. So we are not.
The right way would be in this type of soil and macropores about 24 to 28 meters.
And how much is variation in water table then?
It will be, if the drainage is 1.1 to 1.2 meters, and you will lift it up to 50 centimeters from the surface, it's about 70 centimeters.
Yeah.
You can lift the water table up. Not for the whole time, but for a few days, because the evapotranspiration will go down 5 millimeters per day.
Yeah.
So you can't have the roots in the water the whole time. You have to think about it.